everybody, it's Vedant Popni from grade 6C, and today I'm going to be showing a model depicting the Earth's revolution and rotation. Okay, so how did I make this model of mine? So I have a base disk which contains the sun, and I have an ancillary disk which contains the moon and the earth. Yes. So how did I make them all stay still? I'll tell you that. I used nuts and bolts, put the thermocol balls in there and painted them. Obviously a little bit is poking out of from the other end of this base. So I used cardboard as a hook to hook both the bases together. So what did I do with the sun? So I had a black tube, and I used Feviglue permanent and just put the sun on there, made it rest, and here it is. So let me just show you how it works, one by one, part by one, strand by strand. So let me just rotate this ancillary disk. What are we witnessing right now again? Camera? Oh wait, yeah, we are witnessing rotation, the Earth's rotation, which gives us day and night. Approximately, a day on Earth lasts about 24 hours approximately. It rotates on its axis. An axis is an imaginary line which goes through the Earth. Now the Earth is not always straight. It is slightly tilted. And why am I keep on moving this disc? Yeah, it is tilted. And people believe that it was tilted because some giant meteor hit the Earth and made it tip on one side. Yeah. During its earlier days of formation. So now let me show you revolution. Why don't we? How do I do revolution on this border? Yeah. So as I rotate the ancillary disk, I just push it on. Wait. Yeah. Push it over here. Push it over here. Now, along with our day and night, we're also witnessing revolution, which apparently gives us an year which lasts approximately 365 days. Sometimes, obviously, when there's a leap year every 4 years, we have 366 days. And then it also depends on the tilt of the Earth's tilt side by side with the rotation. And the equator is also there. Now, as we learned about equinoxes, when the sun rays is exactly on the equator, it gives us an equal day of both night and day, 12 hours exactly. Yeah. Wait. Yeah. Oh my god. What did I do? The moon is between the Earth and the sun. Isn't that normal? Well, what happened right here is a solar eclipse. Now wait, I will get to it. So, I will show you, as in there are two shadows which comes from the sun to the moon, and what gives the moon to the earth. So there is an umbra shadow, which is a very dark shadow, or the darkest shadow which falls on the earth. And then there is the pre-umbra, which is slightly darker, not as dark as the umbra. If you are when the umbral shadow is there, you are likely to witness something called a total eclipse. That is the ones you see on Google. The images of solar eclipses you see on Google, usually all of them are total eclipses. That's when the moon fully covers the sun. Okay. And also, disclaimer, it is not good to see solar eclipses because it can cause permanent eye damage even for a few seconds of exposure. So to enjoy a solar eclipse, there are some methods. The most convenient one for you is ellipsis glasses, which are thousands of times darker than sunglasses, and they will protect you from the harmful radiation. Now, at a stage when the moon fully covers the sun and we can't see it, we can't even see any light on Earth. It's like it just suddenly turned night. Then it is safe to take out your glasses, because now the sun rays are not exposing on you, are not coming on you. But immediately before the sun sun rays comes back, please put on your glasses. Okay? Yeah. Now the total eclipse was one of the 4 types of eclipses, and then the second one is a partial eclipse. Now what happens in a partial eclipse? I will tell you. Now the moon does cover the sun, but not fully. Okay, there is, like, you can see a ring of the sun right there. Okay, just a ring, just a tiny little thing, tiny little sheet of paper around the moon in space. Very interesting. Next we have a hybrid eclipse and annular eclipse. So during these two things, moon, it is all about the moon's direction. It can appear from the side, it can appear from the top, and it can be very dim. Okay, it can be very dim. Like this usually happens when you're not in the umbra shadow. You would just see the moon just for a few seconds come in. You can see the sun actually become like a crescent moon, a crescent sun. It looks like we have a crescent. That's a good phrase. Yeah, we have a crescent. So yeah, that's always fun to see. Next, let me tell you what happens next. Okay, let's again show you this right over here. Yeah, and then okay, now tell me what happened. A lunar eclipse just occurred. Why are we having so many eclipses over here? Yeah. Okay. Anyways, so what is a lunar eclipse? A lunar eclipse is when the Earth blocks out the sun's rays from reaching the moon. Now, as you know, this is all about light. So, white light is configured of many colors: red, orange, yellow, green, blue, indigo, purple, the colors of the rainbow. Now, as the sun's rays fall on the Earth over here, there is still light reaches the moon. Alright, and there is the umbral and pre-umbra shadow, umbra and pre-umbra shadow, the dark one and the light one. But what happens is usually the colors have different densities. You can see it's light density. Okay, so some can't penetrate the moon, can't actually affect the moon. But red, the color red shines the most. It is like, it creates an X behind the sun. Okay, which directly falls to the moon. Okay, and then it appears to be red. But now, do remember that during a lunar eclipse, on the other hand, than a solar eclipse, it is safe. So you can enjoy a lunar eclipse without seeing anything. But according to some religions, it is actually it is a bad thing to do. I guess so. Culturally, in the cultural sector, yeah, that's what I've heard about. So yeah, that is that. And enjoy your eclipses. Enjoy. I hope you like this video of me demonstrating my model. If you do like it, please do comment on which part you liked and if you want to see more. Thank you.